Well, welcome to the Aryabhatta PU Science College Physics class, second period of the first chapter, second period of the physics, that is electrostatics, electric charges and fields, second period. In the previous period, we have studied about the unit charges and like charges attract and unlike charges. Like charges repel and unlike charges attract each other, like that properties of electric charges and etc. you have studied. Now you are studying the water conductors and water insulators. What are the conductors and what are the insulators that you have going to study in this class? So what are conductors and what are insulators? So you are in the previous classes, in chemistry classes, you have also studied about the free electrons. In physics classes also, you have studied in the previous year, you have studied the free electrons. So now I am going to recall this. So what are conductors? Here in metals you see iron. Iron is a metal, and in this iron there is a free Fe2 plus. Fe2 plus is an iron. In this 2 plus means it is a valence electrons, valence electrons, and in the same way copper also, copper Co plus 2 plus. So copper free electrons are there in the coppers. Free electrons means positive charged or positive charges are majority in this iron. So these positive charges, they are moving freely in metals. In metals, positive charges, they are moving freely in this. You see the electronic configurations in the periodic chart we have studied. That is the metals, like that. What is metals? Like that. So in any metals there is a free electrons, free valence electrons are there. So these electrons, they are moving, they are always moving freely in the metals. So that is the main cause for the conduction of electrons. The electrons means that is charges. Number of electrons becomes a charges, you see. So charges means the number of electrons, it is a group of electrons that becomes a one charge, positive charge. So that is for charges, there is a movement of free electrons in the metals. So that is the main cause for the conduction. In insulators, there is no free electrons, No free electrons are there in the insulators. They are in the insulators, they are statics. Statics means they are stable. In free electrons are only stable in insulators. To make a movement, we have to rub the plastic or rub the insulators with another insulators. Then only the insulators, they are charged. So that is in the valence electrons, the free electrons and charges, they are the main cause for the conduction in conductors. And in insulators, there is no free electrons. So that is the main cause for the insulators. So what are conductors? What is the main cause for the conduction of substances? So substances which allow the current to pass through them are called conductors. What are conductors? The substances which allow the current to pass through them are called conductors. Example, metals, human body, animal body, earth. Human body, our body is a good conductor of electricity because in our body the liquid is there, that is liquid item, that is blood on our skin. These are the good conductors of electricity. Electrons move freely in our body, so it is a good conductor of electricity. Good conduction. So these are conductors. Presence of free electrons and charges are the main cause of conduction. Due to the presence of free electrons and charges, these are the main cause for the conduction. What are insulators? Give an example. So insulators means same I have given. Substances which do not allow the current to pass through them are called insulators. Substances which do not allow the current to pass through them are called insulators. Plastic, glass, nylon, wood, etc. are the insulators. Free electrons and charges do not move freely in insulators. This is the main cause for the insulators, and this one is the main cause for the conductors, you see. So what are conductors? You have to study this. This is a basic item. I think that this will not given in the examination because it is a basic information. Basic information will not give in the examination. Main information will give in the examination. So, this next one is the insulators we have studied. So, in the previous class you have studied about this what properties of electric charges. In the previous class, in the period first, you have studied the basic properties, that is plus charge. Plus charge is, and another plus charge is there. There is a repulsion between the two same charges, and another minus plus charge is there and minus charge is there. There is a attraction. There is a plus charge and plus charge of the repulsion, or minus charge of the repulsion, and minus charge is repulsion. So next topic we are, so this is the main basic idea for this. Next, Coulomb's law. So Coulomb's law states about the same type of charges or different type of charges. You see, plus charge, plus charge. What is this plus charge? This is a positive charge. This is a positive charge. So this positive charge is, this is a Q. Strength of this is Q1 Coulomb. Strength is Q2. Strength of the first charge is Q1, strength of the second charge is Q2. This is the magnitude of these charges. I think it is maybe a same magnitude. And if it is a plus Q1, this is also plus. This is a plus 2 charges, this is a plus 2 charges. So let the distance between them is R. R is the distance between them, 2 charges. We have to keep one charges here, and there is a distance R between the another charges Q2. And Coulomb's law states that the electrostatic force of attraction or repulsion between the 2 point charges. You see, this is the, if it is a plus and if it is a plus, this is repulsion. If it is a plus and if it is a minus, then it is a attraction. So the force of attraction, this is also R, this is also R. The force of attraction or repulsion, you see, if it is a 2 charges are same, if it is a repulsion, then it is a opposite in sign, this is a attraction. The force of attraction or repulsion. The force of attraction or repulsion. F is the force of attraction or repulsion between the 2 charges. Between the 2 charges is directly proportional to the, this is R. It is directly proportional to the Q1, product of their strength. This is the strength of one charge. This is strength. This is strength, another strength. Q2 is another strength. The force of attraction or repulsion between the 2 charges is directly proportional to the product. Product means into, that is multiplication. Product of the strength, and inversely proportional. Inversely means divided by. Inversely proportional to the square of the distance between them. You see, the force of attraction or repulsion between the 2 point charges is directly proportional to the product of the strength and inversely proportional to the square of the distance between them. This is the Coulomb's law. So Coulomb's law states about the force of attraction, how much force it is there, and how much how much force is between the 2 point charges with respect to the distance between them. That says about the Coulomb's law. So you see, F is proportional to Q1 Q2 by R square. If F is equal to, if we put is equal to, then we have to put K. K is a constant, and Q1 Q2 by R square. Q1 Q2 by R square is the equation. If you remove this proportional, then we have to put constant. You have studied in the mathematics, already studied. So that is the Q1 Q2 by R square. So this is Coulomb's law. Coulomb's law states that the electrostatic force of attraction or repulsion between 2 point charges is directly proportional to the product of their strength and inversely proportional to the square of the distance between them. F is equal to K into Q1 Q2 by R square, where you have to put Q1 and Q2 is equal to point charges in vacuum. We have to put these two charges in a vacuum. Then F is equal to electrical force between the charges, R is equal to distance between Q1 and Q2, K is equal to constant, constant means 1 by 4 pi epsilon naught. So this constant value of this K is K is equal to 1 by 4 pi epsilon naught, and this value is 9 into 10 to the power of 9 Newton. It is a ready-made value and we have to put it here. So K is equal to constant is equal to 1 by 4 pi epsilon naught into 9 into 10 to the power of 9 Newton, and epsilon naught is equal to permittivity of free space. This is, if we put here, one positive charge is there, in between them there is a permittivity of free space is there. So it is a dielectric constant is there, that is a medium is there, so that is permittivity of free space, that is. So we have to put, it is very very important. This question is always arises in the examination. So it is a common question. You have to see in March 2017, 2019, 2020, this question comes here and repeated here on July 15th is there, and model question paper 2021 model question paper also it is there, and 100% surely I am saying that this question comes in the examination. So you have to read it clearly. So state and explain Coulomb's law of electrostatics. Once I am saying Coulomb's law states that the electrostatic force of attraction or repulsion between 2 point charges is directly proportional to the product of their strength and inversely proportional to the square of the distance between them. The electrostatic force of attraction or repulsion between 2 point charges is directly proportional to the product of their strength and inversely proportional to the square of the distance between them. You have to see F is equal to K into Q1 Q2 by R square. Q1 means strength of the one charge and Q2 is equal to strength of the another charge. Q1 Q2 is equal to point charges in vacuum, and F is equal to electrical force between the charges, R is equal to distance between Q1 and Q2, K is equal to constant is equal to 1 by 4 by epsilon naught is equal to 9 into 10 to the power of 9 epsilon naught. This sign means epsilon naught, you have to say it, epsilon, remember this, epsilon naught is equal to 9 into 10 to the power of 9 Newton, epsilon naught is equal to permittivity of space. Okay, you have to remember this, very very important question. And next question, this one also, write the Coulomb's law in vectorial form. You see, force between the two charges is a scalar quantity. Now we have to represent in a vector quantity. What is vector quantity? So that shows one direction. If two charges 1 and charges 2, if they shows some particular direction, then it becomes a vector quantity. If any scalar quantity is there, if 5 is a scalar quantity, if you put a unit vector to this, then R is a one unit vector. If you put a unit vector to this multiply, then this 5 becomes a vector quantity. Any scalar quantity you take, if you multiply that one by a unit vector, then it becomes a vector quantity. Example, you say our 10 is there. If you multiply 10 by 1, then it becomes a 10. Then the value will not change. In the same way, if a 10 is a scalar quantity, if you multiply this by n unit vector, then it becomes a 10 unit vector. Unit vector means it shows a direction in which area, whether it comes from Q1 to Q2 or Q2 to Q1. The force will come from Q1 to Q2 or Q1 to Q2 to Q1. This shows a direction. So, any scalar quantity is multiplied by a unit vector, then it becomes a vector quantity. So, you see vector point 1 by 4 pi epsilon naught. F is a scalar quantity. If we convert this scalar into vector quantity, then we have to put F21. 21 means a force on 2 due to 1. You see here F is electrical force between the two charges, but in vector quantity this is force on Q2 due to Q1, force on Q2 due to Q1. You see. So, in which force it comes to, from which force to which force it is there. So, this shows the direction. So, in which force, the force come from which side, that shows the direction. So, you see force on 2 due to 1 first charge, force on 2 charges due to 1 charge, first charge. That is F21. Q1 and Q2 is equal to point charges in vacuum, and F21 is equal to force on Q2 due to Q1. In the same way, R21 means distance between Q2 to Q1. You have to measure the distance. F21, R21 means unit vector R1. Only R21 means we have to measure from Q2 to Q1, not Q1 to Q2. The same distance, if you measure from Q2 to Q1 and Q1 to Q2, same distance, but it is in a vector quantity. The vector quantity always says a particular direction. So, we have to measure from Q2 to Q1, that is R21. So, this is distance between, R21 means distance between Q2 and Q1. And R2 means unit vector means it shows the direction, the unit vector in the direction of R21 this direction. Q2 to Q1 we have to measure, that shows the unit vector always says a Q2 to Q1. So, that is a unit vector, like and epsilon naught is equal to permittivity of free space. Same example data what I have written here, same you have to write in a vector form. You have to R21. It show these R21, R12, those are all direct, shows the direction. So, this is R21 means 1 by 4 pi epsilon naught into Q1 Q2 by R square. R21 means we have to measure the distance from Q2 charges to Q1. That is a vector quantity. If you simply put the distance, R is the distance between Q1 and Q2, then it becomes a scalar quantity. If it shows the direction, in the vector quantity, unit vector always comes here. Unit vector means it is neither not any scalar quantity. It is a vector quantity. It shows only direction. Multiplication of this unit vector will not changes its value. So, this we need. Write the pictorial representation of the repulsion or attraction between the 2 point charges. I am explaining here. Same that I am explaining in this. For 2 charges, Q1 and Q2 are the 2 charges. Q1 is a plus charge and Q2 is a plus charge. Plus into plus, that means Q1 and Q2 is always greater than 0. If it is a minus Q1, it is minus Q2. This is also repulsion is there, and product of minus into minus plus Q1 Q2 is always greater than 0. So, pictorial representation, that is Q1 and is in this direction, Q2 is in this direction, because they are same charges. So, that is F12 means force on 1 due to Q2. F21 means force on 2 due to Q1. So this forces is going in this side, Q1 is going to this side and Q2 force is going to this side. Q1, Q2 is greater than 0. This is pictorial representation. And for the unlike charges, this is Q1 and Q2. Q1 is plus, plus, another is minus. Plus into minus, minus means less than 0. So that is R21 means 2 to 1. That's one. R2 to Q2 to Q1, because it is in the same in the opposite directions. So distance between them, we have to measure the distance from Q2 to Q1. That is R21. R2 Q1 Q2 is less than 0. So that we have, it is the pictorial representation. This is very, very important questions in the model question paper. It comes in the model question papers. MQP. It comes in my model question paper. Okay. That is Q1 and Q2 is equal to point charges. F1 is equal to force on Q1 due to Q2. F21 is equal to force on Q2 due to Q1. R21 is equal to distance between Q1 and Q2. R21 unit vector R cap is equal to R cap 21 is equal to unit vector in the direction of R21. For two like charges, you have to represent here and you have to write the diagram here. Okay. Next one is Coulomb's law. Coulomb's law in electrostatics. You see. Coulomb's, what is Coulomb? 1 Coulomb. You have to it is a Q1 and Q2 are the many charges are there. It is a 3 or 4 like that. But we have to measure. You have to represent in a unit. Unit means 1. So that is there. 1 Coulomb. What is the meaning of 1 Coulomb or unit? Unit charge. Unit charge means only one positive charge. This is one charge. What is the meaning of unit charge means? You see, F is equal to Q1 Q2 by F is equal to Q1 Q2 by R square. If F is equal to K means 9 into 10 to the power of 9 Newton. Put in the value of K 9 into 10 to the power of 9 into Q1 Q2. Q1 means unit charge. Only one charge. 1 Coulomb of charge. This is 1 Coulomb. This is 1 Coulomb of charge. This is 1 Coulomb. You put 1 Coulomb into 1 Coulomb divided by distance between them R is 1 meter. Unit meter. 1 meter. Then what is this value becomes 9 into 10 to the power of 9 Newton. This is Newton. F is equal to 9 into 10 to the power of 9. We have to convert this into unit manner. So unit charges means you see 1 Newton. A force becomes 1 Newton. Force becomes 9 into 10 to the power of 9 Newton when a unit charge 1 Coulomb of charge of the same magnitude, another 1 Coulomb of charge placed 1 unit charge placed at a distance of 1 meter, 1 meter square. 1 square means 1 meter square. So this is the unit charge. You see, Q1 is equal to Q2 is equal to 1 Coulomb. R12 becomes 1 meter. Distance between R1 and 2 is 1 meter. Then F is equal to becomes 9 into 10 to the power of 9 Newton. You see, 1 by 4 pi epsilon means 9 into 10 to the power of 9 Newton. So what is 1 Coulomb? 1 Coulomb is the charge that when placed at a distance of 1 meter distance from another charge of the same magnitude. This is plus charge, this is 1 Coulomb, the same magnitude. In the vacuum experiences an electrical force of repulsion of magnitude 9 into 10 to the power of 9 Newton. This expression you have to write. 1 Coulomb is the charge when placed at a distance of 1 meter from another charge of the same magnitude in vacuum experiences a force of 9 into 10 to the power of 9 Newton. So that is 1 Newton. So that is 1 unit charge. Unit charge or 1 Coulomb. 1 Coulomb means 1 Coulomb is the charge that when placed at a distance of 1 meter from another charge of the same magnitude in vacuum experiences an electrical force of repulsion of magnitude 9 into 10 to the power of 9 Newton. So that is the, you see, or you follow. Next one is, what is the effect of electrostatic force between the 2 point charges? You see, there is electrostatic force of between the 2 point charges. Is that 2 points? What is the electrical force of attraction? Force between the 2 point charges when a dielectric slab is between them. Here there is a air is there. If a slab, dielectric slab is there, or wood or plastic is in between them, then what is the electrical force? Electrical force becomes decreases. Electrical force decreases when a dielectric slab is in between them. Slab means plastic or wood or that is any insulator is in between them, then it decreases. Electrostatic force between them is zero when a metal is in between them. If a metal slab is in between them, then there is a easily flow of electrons. The charges will easily flow from this point to this point, then the electrical force becomes zero. So that is, yes, dielectric slab is introduced between them, then the electrostatic force decreases. And metallic slab is introduced between them, then their electrostatic force becomes zero. So these are the explanations. So in this 7 questions are there in this period, you have to write it in the notes clearly. And this what I am underlined the questions, that is very very important. See, it comes in this one, what is Coulomb defined unit charge, it comes in March 15th examination. So it comes very very important, you have to write down. You write down in the notes. The next one is the memorizing part. Memorizing part means I explained 3 times. One single answers I am explaining, I am going to say 3 times, then it is very very easy to memorize. Okay. Now I am going to explain the single, that is these answers 3 times. I am saying only, just I am only saying 3 times. You have to listen carefully, listen clearly and write it 2 times. By seeing 1 time and without seeing another time, in a rough book you have to write it here. Next, what are conductors? What is the main cause for the conduction of substance? The substances which allow the current to pass through them are called conductors. The substances which allow the current to pass through them are called conductors. The substances which allow the current to pass through them are called conductors. Example, metal, human, animal, body, etc. Presence of free electrons and charges are the main cause of conduction. Presence of free electrons and charges are the main cause of conduction. Presence of free electrons and charges are the main cause of conduction. You have to write this in a rough book by seeing 1 time and without seeing another time. You have to write it. What are insulators? Give example. Substances which do not allow the current to pass through them are called insulators. The substances which do not allow the current to pass through them are called insulators. The substances which do not allow the current to pass through them are called insulators. Example, plastic, glass, nylon, wood, etc. Free electrons and charges do not move freely in insulators. Free electrons and charges do not move freely in insulators. Free electrons and charges do not move freely in insulators. Next, state and explain Coulomb's law. Very important question. Coulomb's law states that the electrostatic force of attraction or repulsion between 2 point charges is the electrostatic force of attraction or repulsion between 2 point charges is the electrostatic force of attraction or repulsion between 2 point charges is directly proportional to the product of their strength. Directly proportional to the product of their strength. Directly proportional to the product of their strength and inversely proportional to the square of the distance between them. Inversely proportional to the square of the distance between them. inversely proportional to the square of the distance between them. Q1 and Q2, point charges in vacuum. F is equal to electrical force between charges. R is equal to distance between Q1 and Q2. K is equal to constant, is equal to 1 by 4 pi epsilon naught, is equal to 9 into 10 to the power of 9 Newton. Epsilon naught is equal to permittivity of free space. You have to write out it. By seeing one time and without seeing another time, you have to write it in the rough. Write Coulomb's law in vector form. 1 by F21 is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R21 square into R cap 21. Q1 and Q2 is equal to point charges in vacuum. F21 is equal to force on Q2 due to Q1. R21 is equal to distance between Q1 and Q2. R21 is equal to unit charge in the direction of R21. Epsilon naught is equal to permittivity of free space. Yes. Next question. Write the pictorial representation of the forces of repulsion and attraction between the 2 point charges. From this to this one, you have to write it 2 times in rough, because it is a representation, it is just memorizing part, this one. You have to write as it is, because it is same repeated here. You have to write on. I think you can write it very easily. Define 1 Coulomb or define unit charge. F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R12 square. If Q1 is equal to Q2, 1 is equal to 1 C, 1 Coulomb, and R12 is equal to 1 meter, then F is equal to 9 into 10 to the power of 9 Newton. 1 Coulomb, do you remember it? Listen carefully. 1 Coulomb is the charge that when placed at a distance of 1 meter from another charge. 1 Coulomb is the charge that when placed at a distance of 1 meter from another charge. 1 Coulomb is the charge that when placed at a distance of 1 meter from another charge of the same magnitude in vacuum, of the same magnitude in vacuum, experiences an electrical force of repulsion of magnitude 9 into 10 to the power of 9 Newton. Experiences an electrical force of repulsion of magnitude 9 into 10 to the power of 9 Newton. Experiences an electrical force of repulsion of magnitude 9 into 10 to the power of 9 Newton. And you have to write it this in one time by seeing and another time without seeing in the rough. You have to write it. What is the effect of electrostatic force between the 2 charges when a dielectric slab is introduced between them, a metallic slab is introduced between them? Electrostatic force decreases. Electrostatic force decreases, and electrostatic force between them is 0. Electrostatic force between them is 0. You have to write it here and write it in a clearly, and by seeing one time and without seeing another time, you have to write it in a rough. Okay, and you have to write it and send that homework into my WhatsApp number. I will make a correction to you. Okay, best of luck. And in the same way, from starting to ending, you have to listen this my notes, and you have to write it my notes clearly. Then you can get a very good marks in the examination. And one who are not subscribed in my channel, you have to subscribe it, and whenever a new information is there, I will send it first to the subscribers, and I will also if possible at the time of examination, I will conduct the online classes for the subscribers. Okay, best of luck.